Hello everyone, my name is Chris Kim, and in this video we're going to talk about decorators on the Beaker framework. Beaker provides several decorators that simplify your smart contract code by letting the application know how to handle methods that are configured by decorators. Let's see what kind of decorators Beaker provides. The external decorator decorates methods to be handled as ABI methods. In other words, the external decorator handles all of the routing within the smart contract so that when the smart contract receives a no-op application call, which is just a normal app call with no side effects, it knows when to execute certain external methods. Let's take a look at a simple smart contract example called external example app to see how external decorators work. So here we're creating an application called external example app here in line 4, assigning that to the app variable. And this application has one external method called the add method. It takes in two arguments, a and b, and it returns an output where the output is set to a plus b. Now here in line 7, you see the app.external decorator. Now if you remember the application class video, I mentioned that the application class include decorators to handle different types of application calls. Hence why we are using the external decorator from the app variable, which is an instance of the application class. So what this app.external decorator is doing is, if you remember the first video where we did a comparison of a calculator app written in Beaker and just bare PyTeal. And if you remember the PyTeal one, it had this thing called a router, where the router handled routings of different types of application calls that the smart contract receives. That's how the smart contract knows what methods to execute when they receive an application call. But as you can see in this Beaker smart contract, we don't see a router defined. This is because this app.external decorator is handling the routing under the hood, so that without you having to manually define the router, this one line of code handles the routing for you. For some external methods that are just reading and returning certain data and are not sending a transaction to the network, can be flagged as read-only. When the method is flagged as read-only, you can send the app call to the method as a dry run to simulate the method without sending a transaction to the network. Therefore, you don't need to wait for the blockchain to confirm the transaction and pay transaction fees for calling a read-only method. Now, even if a method is flagged as read-only, it's only giving you an option to simulate the method call. So if you just call the method, it will be a normal transaction with fees and wait time. Moving on to adding authorization logic to a method. Now, when you're creating your smart contract, you may want to only allow certain people to have access to some of the methods in the smart contract. Because hey, if you create a ticketing app that has a withdraw method meant for the creator of the smart contract, and if everyone can call that method, the creator of the smart contract is not going to be happy. So in this case, to make a method callable only to the creator of the smart contract, you can do so by adding this code. Now this withdraw method is only callable by the creator of the smart contract. You can also require the transaction sender to hold certain assets or require them to have opted into the smart contract to call the method. If you want to define your own custom authorization logic, you can do that as well. For more information and examples, check out the Beaker documentation. The link is in the description. When sending an application call transaction with the Algorand SDK, there are different types of application call transactions with different Oncomplete parameters. These are the possible Oncomplete parameters you can set when sending an application call transaction. If the app call transaction is a no-op Oncomplete transaction, it simply executes the approval program of the smart contract. On the other hand, all of the other Oncomplete calls have additional actions when calling a smart contract. For example, if the application call is an opt-in application call, it will opt in the account that's calling the application and also execute the smart contract logic in the opt-in method written in the smart contract. I'll leave a link in the description to the dev portal where you can learn about these Oncomplete calls. Let's see how to do this by looking at some code. Alright, let's take a look at this application called the Oncomplete app. This application has all of the Oncomplete decorators defined in it. So let's take a look at each one and see what they do. Here in line 11, we have a method called opt-in, and it is decorated by the opt-in decorator. So this opt-in method will be called when the app call is an opt-in app call. Down here, we have a closeout method, which is decorated by the closeout decorator. So this method will be called when the app call is a closeout app call. But as you can see, this is returning reject here. So what this means is whenever an account is trying to opt out, which is the same thing as close out from this smart contract, it will reject that transaction. So the account won't be able to opt out of the smart contract. For these kind of cases, that's why we have the clear state Oncomplete application call. So this clear state method is decorated by the clear state decorator, and this one is approving. And even if this is rejecting the clear state app call, the clear state application call will always let an account opt out from the smart contract. So we'll see what this looks like when we deploy and call these methods. Down here, we have a method for update, and we also have a method for delete. Now, for the delete method that is decorated by the delete decorator, it has an authorization logic written right here. And remember, I talked about authorization to only allow certain accounts to call the method. So here, we're setting authorize to authorize.only global.creator address. So what this is saying is I'm only going to authorize the creator of this smart contract to call this delete method. So this is how you can limit access to certain methods in a smart contract. All right, now let's go to Oncomplete deploy.py file to see how the Oncomplete decorators work. So here we're building and exporting the artifacts to the artifacts folder, and then we're using sandbox module from Beaker to get a list of accounts from our local network. And then I'm assigning the first account to the creator variable and the second account to Alice variable. Down here, I'm creating an application client using the creator address. And then I'm going to use the app client to create the smart contract. Then I'm going to try opting in using the opt-in method call defined in the application client. And as you can see in the definition, this opt-in method provided by the app client is submitting a signed application call transaction with Oncomplete set to opt-in. So you can see that this is an opt-in application call. So when the smart contract receives this app call, going back to the contract, it knows to call this opt-in method because it is decorated by the opt-in decorator. Going back to the deploy file. Next, let's try closing out, which means opting out of the smart contract. But remember, the closeout method is rejecting any transactions. So this app call should fail and print out the error message. And then the app client is going to call clear state method, which will forcefully opt out the account and then print out this message right here. Now let's create another app client using the prepare method of the app client to create a client for Alice. Now Alice is going to try and delete this smart contract. But remember, going back to the contract, the delete method was decorated with the authorization logic to only allow the creator of the smart contract to delete the smart contract. So this app call should fail and print out this error message right here. And finally, we're going to use the creator's app client to delete the smart contract. So let's go to the terminal and see what this looks like. So I'm going to call Python 3 and then run the deploy file. And there, we created the app here, opted into the contract. We tried closing out, but it failed and printed out this error message. So we used the clear state method to opt out of the smart contract. And then Alice tried to delete the smart contract, but because of the authorization logic, it failed. And the creator app client successfully deleted the smart contract. Lastly, if you want to define a utility type method that is used internally by other methods in the smart contract to handle complex logic, you can do so by decorating the method with PyTeal subroutine decorator. These methods are not exposed to the ABI, which means the front end will have no idea how to call these methods. If you want to learn more about PyTeal subroutines, watch the subroutines video from the Master PyTeal series. Alright, let's take a look at this application called Internal Subroutine Example App. This application has two methods, an add method, which is an external method, and it takes in two arguments, A and B. But notice how it's returning something different here. We're still setting the output to something, but here inside of it, we're actually calling the internal add method to actually add A and B. So let's take a look at the internal add method here. This internal add method is decorated by the subroutine PyTeal method. When you decorate a method with the PyTeal subroutine method, the method is not exposed to the ABI, and therefore the front end won't know how to call this method. So if you need to define a utility type method that can be reused within the smart contract, you want to use this subroutine decorator. So let's look at what this internal add method is doing. It's also taking in two arguments, a and b, and is returning a.get plus b.get. So the actual adding part is defined in this internal add method. So once the internal add method add a and b, it returns the value, and that value is set to the output, and the external add method returns that output. So let's see what this looks like. I'm going to the deploy file. We're going to build and export the app again. Going to create the application client here, create the application, and then let's try calling the internal add method here. As you can see, there's a red line, but let's just try it anyways. So we're going to try calling the internal add method and add 1 and 2. And if that fails, it will print out this error message. And then down here, let's try calling the external add method with the same two arguments, 1 and 2, and see what that looks like. So going to the terminal, and let's run the deploy file. And you can see that the error message popped up because the app client tried calling the internal method, and when we called the external add method, it returned the result 3. Today we learned about decorators and how they simplify smart contract code. We learned that the external decorator exposes the method to the API. We learned that you can add authorization to only allow certain accounts to call methods, and also that the read-only flag lets accounts call methods without paying for transaction fees and waiting for network block time. We also learned that with Oncomplete Decorators, you can customize what happens during Oncomplete application calls, and to make a utility type method for internal purposes, you use the PyTeal subroutine decorator. As always, if you have any questions about the video, head over to the official Algorand Discord channel and get help from our developer relations team. That's it for today. Let's move on to the next video.